Okay, hi everyone, or most probably just Thea. I was just going to go through this polar coordinates question because she asked me about it, and I did try and set one, which I thought was going to be quite nasty. In the end, actually, I don't mind this one, but I mean, don't get me wrong, polar coordinates questions they're not easy. They're a lot of hard work. They can be confusing, they can be a bit baffling. So yeah, I totally understand. If you're stuck on this one, it's not an easy, this topic's never easy. That said, it's quite an interesting question. Because I mean, just look at the domain, the way they've changed the domain. They've said, okay, for this polar coordinate curve, it's only defined from minus pi over 4 to pi over 4 and 3 pi over 4 to 5 pi over 4. And that's what it looks like on the diagram, because I reckon that's about 45 degrees pi over 4. And that's going to be like, under the initial line minus pi over 4. So the curve only goes that far and that far. Likewise, at the back of it, I reckon that's like 3 pi over 4 from there round to there up to pi. And so this bit is basically the angles of 3 pi over 4 round to 5 pi over 4. So just have a look at the question sometimes and have a look at it and think, does it make sense? And then think, yeah, actually, it really does. It's making a lot of sense, that. I'm just going to, sorry, because I'm using this new bit of software, it's not quite as quick as the other one I was doing it with. Maybe I should go back to what I was what I was good at before, but I just wanted to try something different and something which wasn't going to advertise to me relentlessly, because I do hate adverts. I really do hate adverts. Anyway, let me just quickly get rid of this. So here's the question. I'm going to go through the whole lot of it as well. I think Thea only asked for help with a second part, but nonetheless, it's good to start right from the start and just get a hang of it. I suppose it won't matter too much if that's on there. Okay, weirdly enough, the first question says find the total area enclosed by the curve C shown unshaded inside the rectangle. So we're going to work out the area of these bubbles. Now, personally, I don't know about you, but when I see symmetry with polar coordinates, I think, great. What I'm going to do is I'm just going to integrate from 0 to pi over 4 and then times it by 4. In other words, I'm going to work out the area of that and then multiply it by 4, so I've got the area of the two, I don't know what to call them, like the two circly objects here. Okay. Oh yeah, that's where the rubber is. Let's get the rubber out. Here we go, now we're good. Okay, so um what I'm going to do then first is I'm going to do part A, and all I need for that is just a half r squared d theta. That's all I'm using, that formula, from 0 to pi over 4. But because I'm only going from 0 to pi over 4, which is only going to find me this top half here, I'm going to times that by 4. Yeah? Now, that is going to clearly equal 2 times. Okay, if we square this, we're going to get 9 cos 2 theta. Yeah? From pi over 4 to 0. And so, personally, I take the 9 out to make that 18. I'm then going to integrate cos 2 theta, which is sine 2 theta over 2, and pi over 4 and 0. And now I can just plug that in. Sine of pi over 2 is 1, so sine of 0 is 0. So you're just going to have like 18 times a half, which is 9 units squared. So that one's nice and easy. That 4 marks is certainly not too bad at all. I just wanted to quickly mention, why aren't we defining it from like pi over 4 to 3 pi over 4? Well, it's because you've got a square root in there. That's what the half means. And when you get cos of, say, pi, well, that's minus 1, and you can't square root minus 1. That's why the curve's not defined from this region up to this region. I just forgot to mention that, and I thought I'd better, because the question makes more sense then. You can see what's going on. Okay, so let's go down to the nastier bit. The nastier bit is find the region bounded by the curve and the 4 tangents shaded in figure 1. Now, first thing I thought was, is it really asking me to work out the area of a rectangle? I read the question again. I thought, yes, that's exactly what it's asking me to do. So there must be something difficult about finding the area of this rectangle. And indeed there is, because whilst the width, if we take the width to be the distance from R to S, whilst that width looks fairly obvious, my first thoughts were, am I allowed to use the fact that this is obviously at the point theta equals 0? Because if it's at the point theta equals 0, and you can see from, because it's on the initial line that theta equals 0 there, well, cos of 0 is 1. 1 to the power of a half is 1, times by 3 is 3. In other words, from the origin up to there is 3, and therefore this width is 6. Yeah, and I thought, well, hang on a second, I'm going to do this in 2 marks. This cannot be right. But the problem is finding the height there, yeah, finding, in other words, the distance from Q to R. That's the difficult bit, but the width from S to R is really, really easy. Now, the way you find tangents, or the way I find tangents, is you got to think of it like this. I normally think, well, I'm looking for the flat points, yeah, so I know that dy by dx is 0 when I'm looking for, the flat turning points, if you like. The flat turning points is where dy by dx equals 0. Now, as dy by d theta divided by dx by d theta is going to be dy by dx. If I remember that, and I also remember that dy by dx is infinite for the vertical turning points, if you like, but for the horizontal, it's like that, then I basically can remember. I've got an easy way then of remembering whether it's dy by d theta, which is 0, or dx by d theta, which is 0. I hope that makes sense, because I didn't have to look that up. Even though I haven't taught polar coordinates this year and it's been a while, these little kind of tricks help you, when you don't know what to do. So yeah, because dy by d theta divided by dx by d theta is dy by dx, we can see that we need dy by dx to be 0. In other words, we need dy by d theta to be 0 when we're finding the horizontal tangents. So that's really important. Dy by d theta is 0 for the horizontal tangents. This is a nicer writing thing than the Miro board. I must admit, I'm quite impressed with that. Okay, anyway, so dy by d theta. Well, I better write down what y is. Now, if you remember, y is always r sine theta, yeah? And you can get that from just putting on a plane. This is r and this is theta. Well, that is your x and that is your y, isn't it? Yeah. In other words, that's your y and that's your x. Maybe it's better looking at it like that. And then you can just see, well, y is going to be r sine theta, x is going to be r cos theta, just from SOHCAHTOA trig, basically. And so we've got y as r sine theta, but don't forget, we've got to plug r in as 3 cos 2 theta to the half sine theta. Yeah, and so we can now see why this question's hard. To differentiate that, I'm going to need product rule. So I'm going to get 3 cos theta if I differentiate the sine bit first, cos 2 theta to the half. And then I'm going to differentiate the cos 2 theta to the half. So I'm going to get plus 3 times now. This is going to take a little while. Well, let's put the sine theta in first. Now let's differentiate the cos 2 theta, and that differentiates to minus 2 sine 2 theta. Let's bring down the half as well, and let's also multiply by cos 2 theta to the minus a half. Can I fit it all in? Just about, yeah. So yeah, it's a long old expression, and we know that equals 0. So immediately you can kind of cancel the 3's, and that 2 is going to cancel with that half as well. And so we're going to be left with this cos 2 theta, sorry, cos theta, cos 2 theta to the half minus sine theta, sine 2 theta over cos 2 theta. Multiply it all by cos 2 theta, to the power of a half, sorry. Multiply it all by cos 2 theta to the half, and you're going to get, so what I'm doing here is I'm timesing everything by cos 2 theta to the half, and you're going to get cos theta, cos 2 theta, minus sine theta, sine 2 theta. You always get pretty patterns coming out of these kind of questions, you really do. Polar coordinates are like that. Okay, so we're in this lovely position. I kind of then thought, should I convert to tan or something like that? In the end, I thought, no, use the double angle. So I put them all, I put it kind of neatly on one side and on the other. But then I thought I really need double angles, so it's all single angles. So I thought I'm going to turn everything into sine. And I only realised that would be the way to go when I changed this into, because I have no choice with this, 2 sine squared theta cos theta. And I thought, well, the cos thetas, I'm not going to cancel them. I'm honestly not going to cancel them. What I'm going to do is take it all onto one side. I'm going to have 1 minus 2 sine squared theta minus 2 cos theta. If I write that down first, it might be a bit clearer. I don't know. Sine squared theta equals 0. And then I factorized. So what did I end up with? I ended up with this. Cos theta 1 minus, now you're going to have 2 sine squared theta, then minus another 2 sine squared theta. So you're going to have 1 minus 4 sine squared theta there equals 0. Now you might think, okay, cos theta equals 0. But cos theta equals 0 at pi over 2. Go back to the question. Pi over 2, that's in the no-go zone. That's at 90 degrees. So it's not defined for that value. So, and it's the same for 3 pi over 2 as well, if you look carefully. 3 pi over 2, it's also not defined for, because that would be down here. And so you can ignore that. I'll write it down, but then go, ignore. Out of range. In which case, it must be sine squared theta, which is a quarter. In which case, sine theta is a half or minus a half. In which case theta is, right, let's do this. That will give you pi over 6 because it's 30 degrees. 180 minus, well, that's 5 pi over 6. We'll check all these with a range in a second. For minus a half, you're going to get minus pi over 6. And then you can do pi minus pi over 6, which is 7 pi over 6. And if you check carefully, every single one of those values is in the range. And what's more, it looks right. And that's one bit of advice I'd always give you on these questions. Does the angle look plausible? Yeah, because that one and that one must have the same angle there and then. We're basically saying that's pi over 6 and that's minus pi over 6. Does that look equally as, 5 pi over 6 round here? Yeah, because that could easily, because this has got symmetry down there, hasn't it? So that looks very right to me, because that looks like, 5 pi over 6, which would leave a minus pi over 6 there. It's minus pi over 6 down there, but 5 pi over 6, that looks really right. And I can't remember what the other one was, 7 pi over 6. So you're going turning all around a pi, and then another pi over 6 down there. They just look right. Okay, so we've got those values. Now, you might think, so what? Well, I definitely didn't think so what. I thought bonus, because if we just, I tell you what, can I just copy in the question again down there? Because it really helps to draw on a diagram here. 1 second, I'm just going to copy the question back and pop it in. Oh, don't mean to, I actually wanted to move it up. Am I moving it up or down? I really don't know what I'm doing here. It's like I move it up and it just doesn't move down. Oh, here we go. Has that moved it up a bit? Oh, I don't want to stretch it. What a wally. Oh, I don't know. Well, this will do. Right. Okay, so it's there. Okay, so we've got those values, and why is that really good news that I found that? Well, I can just plug in now pi over 6 into here, yeah? And if I plug it in there, I find r, which means I'll know that distance from there to there, which means I'll be able to use SOHCAHTOA, and I ended up calling this x, even though it's kind of a y coordinate. I just called it x. Tell you what, to avoid the confusion, I'll call it p for you, if you like. Let's call this side p, because if I find p, I've just got to double it, and I've got the width, and I'm really, really close to the answer then. Well, plug theta equals pi over 6 in there. You get cos 2 pi over 6, which is cos pi over 3, which is cos 60, and that's a half. A half square rooted is 1 over root 2. Times it by 3, you're going to get 3 over root 2. So in other words, that side is 3 over root 2. Yeah, I believe. You can check that on a calculator. And so what have we got here? Well, we've got sine of pi over 6 equals opposite divided by 3 over root 2. Sine of pi over 6 is a half. Times it by 3 over root 2. You're going to get 3 over 2 root 2 is p. Brilliant. I've now got everything I need to find the shaded area, because I just need to work out the area of the rectangle and take away part A's answer. So double p is going to be 6 over 2 root 2, which we could easily write as 3 over root 2. And if you're a rational kind of person, I'm not. Right, that's 3 root 2 over 2 if you like. Okay, we can now work out the area of the rectangle. It is, if you remember earlier, the width was 6, and this is 3 root 2 over 2. And so that's going to be 9 root 2 actually, because 6 times 3 is 18, divided by 2 is 9 root 2. And thus, shaded area is 9, which was that part A's answer. Oh, sorry, it's going to be the area of rectangle minus part A's answer. So it's going to be 9 root 2 minus 9, or if you like, 9 root 2 minus 1. Happy days. All done. 9 marks. I did actually quite anxiously check the mark scheme after I finished this because I was worried about the way I'd found the 6, like just by sight. I just eyeballed the diagram and went, well, that's where theta's 0. So I'll plug in 0, I'll find r is 3 from there to there, and then I'll double it because it looks symmetrical. I was worried that they might ask me to use dx by d theta equals 0 and to work it out like the proper way. It wouldn't have been that bad, really. We would have just used dx by d theta rather than dy by d theta. It all would have worked out. But interestingly, when I checked the mark scheme, they took it as obvious that that was 6 across. So I was like, oh, that's good to know. Okay, I hope that was useful, Thea, and anybody else watching. Carry on the good work. Bye bye.